Hello and welcome back to Ganesh Institute channel. So in today's video we are going to discuss about Lagrange's interpolation. So when do you need to apply Lagrange's interpolation? When you already have so many formulas which you can see: Newton's forward, Newton's backward, Gauss forward, Gauss backward, and so on. So if you see in Lagrange's interpolation, so far we have been doing when we are given with equal intervals, right? If 5 is there, then 10, 15, 20, something like that. But as you can see, the difference between these two terms is 1, then difference here is 3, difference here is 2. So this is unequal interval, right? Unequal interval. And then if you are having unequal intervals, then Lagrange's interpolation formula comes into picture. So as you can see, question is asking for the value of y or fx at x equals 10. That means in between these two. So for that, you need to apply Lagrange. Let me tell you a simple bit how I was trying to write down the formula here. But let me give you a scenario where you can just do it without any formula. If you need to find out the value of any polynomial fx when x is not known to you, so what you need to do, this is your first term, right? This is your first value. So leave this, you need to hide this, just don't think about it for a moment. And it is x term, right? These all are 6, 9, 11 are x term, right? So mark it as x minus 6, x minus 9, x minus 11, right? And you need to multiply it and divide it with the values here. May I know what is your x value for the first term? X is 5, so substitute 5 in place of x, right? If you see in numerator, you have got x term factors, and now substitute the value of first x in place of x, okay, just like you can see here. And in multiplication, you need to multiply it with y term, which is 12, as you see for the first, right? Similarly, keep going on with other values as well. So for this, for second term, hide second value. And now moving on with the same part, x minus 5, then x minus 9, then x minus 11 divided by, just substitute at the value, instead of value of x, substitute the second counterpart of it, which is 6 minus 5, 6 minus 9, 6 minus 11, right? And multiply it with that value which you hide. If you see here, the frequency, the y value is 13, right? And then keep going on with the third value. Now you are going to hide your third value, which is this. So now your x will be this for denominator, and for multiplication you need to choose 14, right? Rest of the part will remain same: x minus 5, x minus 6, x minus 11. Then let me write down x minus 5, x minus 6, x minus 11. In denominator, substitute in place of x what? The value which you hide. This x is 9, right? 9 minus 5, 9 minus 6, 9 minus 11. And in multiplication, your frequency, which is for the hidden value, 14, right? Then the last bit, which is again, if you see, this need to be hidden. So rest all, x minus 5, x minus 6, x minus 9, right? And then in denominator, substitute at x, substitute x as 11, right? 11 minus 5, 11 minus 6, 11 minus 9, multiply with the hidden frequency, which is 16, right? So this is your value. Now if the question would have asked you not to find out any particular value, but instead just the polynomial fx, then you need to simplify this by taking common and all, and leave it as it is in terms of x. But if question is particularly asking at some value, so put that value in place of x. So put x as whichever value is asked for, 10, right? So x is 10 here. So if you put here 10 minus 6 is 4, 10 minus 9 is 1, 10 minus 11 is minus 1. So 4, 1, minus 1, multiply 12, divide by 5 minus 6 is minus 1, 5 minus 9 is minus 4, 5 minus 11 is minus 6, right? Multiply by 12 here. Then you have this x minus 5. If you put x as 10, 10 minus 5 is 5, 10 minus 9 is 4, 10 minus 9 is 1, then 10 minus 11 is minus 1, then in denominator you have 6 minus 5 is 1, 6 minus 9 is minus 3, 6 minus 11 is minus 5, and here you have 13, right? Then here x is 10, 10 minus 5 is 5, 10 minus 6 is 4, 10 minus 11 is minus 1, then 9 minus 5 is 4, 9 minus 6 is 3, 9 minus 11 is minus 2, into 14, right? Plus again x as 10, 10 minus 5 is 5, 10 minus 6 is 4, 10 minus 9 is 1, into 16, divide by 11 minus 5 is 6, 11 minus 6 is 5, 11 minus 9 is 2, right? Now solve this value for f10. So if you see, minus is cancelled with minus, 4 with 4, 6 times 2 is 2, 12 I have written 2 times, right? This is nothing because 12 is already here. Now if you see, what we are left with, only 2, right? And this minus is cancelled with minus, so only 2. Then here 5 is cancelled with 5, minus with minus, 1 minus is left, right? 13 by 3. Then 4 with 4, minus with minus, 2 times 14, 2 times 7 is 14, so 7 5 is 35 by 3. And here you have got 2 times 2 8 is 16. Then you can mark this 2 to the 4, 2 to the 6, so 16 by 3. So if you see 2 minus, you can take 2 plus, this is 3 as LCM, minus 13 plus 16 is 3, 35 and 3 is 8, right? And then 3 to the 6, so we have got 44 by 3, right? So in this way you can apply Lagrange's interpolation to find out any term if you are given with unequal interval. But you know, if you see in Lagrange's interpolation, this we applied because only 4 terms are given to us, and for 4 terms we can do this, and x equals 10 is making it easier, right? But what if a bigger number is given and more number of x and more number of values are given to you? Then we can apply Newton divided difference. Let's see how it works in our next video. Till then, take care and don't forget to like, share and subscribe my channel. Bye bye.